Hi, welcome to this talk on microservices. I'm Sanjay Goil. I'm part of the product management team in the Oracle database. With me, I have Paul Parkinson. I've been at Oracle for about 3 years, and Paul and I have been working to make app dev simpler with the database. I'll let Paul introduce himself, and then we'll go from here.
Thank you. Hello, my name's Paul Parkinson. I've been at Oracle 20 years now, focused entirely of those 20 years on transaction processing and modern application development. And so that now means microservices, and a very important part of microservices being observability. So we've really delved into that and look forward to talking to you about it today.
We're happy to have you here. And let's dive into what microservices are, what app dev patterns are, and then kind of dive deeper into observability. So, next slide, Paul. So, as a brief agenda, we'll talk a little bit about modern app dev. What are your challenges? What do we see as successes and failures with our customers? And then Paul will dive more into open telemetry, Grafana, and the whole idea of a unified single screen for helping diagnosability, for helping performance tuning, and other things. So, anyways, we'll dive deeper. There's a lot of content here, so let's get on with it. Next slide, Paul. So with modern app dev, you see that there are 12 microservices principles, and think about bounded context, loose coupling, CI/CD. But here we're going to talk about unified observability, and there are other talks during Oracle CloudWorld that you might want to check or stop by our demo booth where we talk a little more about these patterns. So without further ado, let me hand it over to Paul to talk about unified observability.
All right. Thank you so much, Sanjay. So the first thing we're going to do is start at the beginning. Why open telemetry? Why are we using open telemetry for observability? As Sanjay said, at this point, if you're using microservices, you're probably well aware of why observability. It's just absolutely necessary. And so then it's a matter of being efficient and making these tools more useful. And so that's one of the answers to why OpenTelemetry. So first, to define it, OpenTelemetry is a collection of tools, APIs, and SDKs, and it's used to instrument, generate, collect, and export telemetry data. And so telemetry data is metrics, logs, and tracing. You can divide that. They have their each special characteristics, which is what I find interesting. But really, metrics, logs, and tracing are the three groups, and OpenTelemetry deals with all of them. So, OpenTelemetry is what we want to choose because it is a cloud-native CNCF standard. Okay, so we're moving into this modern app dev. And it really, when you look at it, it comes down to two goals. The main goal is to consolidate the number of different standards out there now. With microservices, you have all these different, potentially different and disparate systems using different standards. And so OpenTelemetry, since it started in 2019, one of the main goals has been, making a common umbrella, if you will, or adapter to these existing standards so that everything can work together well. And then the other kind of goal has been automation, reducing or removing the need to make app code changes. Because if you're, especially if you're working with legacy systems or whatever systems they are, you may not be able to touch the code. You don't want to touch the code, to instrument with these cross-cutting concerns such as observability and things like that. So OpenTelemetry is devised and defined ways, and I'll elaborate on that, to achieve observability without actually modifying your source. And so going through the three pillars, as they call them, metrics, Open Metrics is Prometheus-based. It's all based out of things that were being used predominantly in the industry anyway. Logs, and so open logging is kept very general because logs have been around, for decades and decades and have a number of different formats. So that has to be fairly open. And a lot of open logging is, defining regular expressions and common logging formats and things like that, and using those sets and tools. And tracing. And, of course, Zipkin and Jaeger have been the popular tracing mechanisms. So they form, what used to be open tracing is folded into OpenTelemetry. Okay. And this is essential. Good tools in observability are essential for microservice architectures for modern application development. Now, why Grafana? Grafana in some ways speaks for itself by its market presence. This is the most popular observability visualizer. And these are some of the reasons why. It's very lightweight, open source alternative to some of the other Elasticsearch, Splunk, things like that are out there. But at the same time, it's not a mutually exclusive solution. So if you have particular tools, such as different Oracle tools, it doesn't mean that you would not use them per se, but that might be a more special purpose. Grafana is great for this overall observability that we're talking about. And that goes to the point of the single pane of glass. And it's a predominant theme in this presentation, is the ability to see metrics, logs, and tracing in the same single pane and across tiers. Okay. And of course, that has support for all these open technologies such as Prometheus. And it's very well designed because, for example, you can bring in Prometheus Alert Manager alerts into Grafana. So you're not reinventing everything. You're bringing it into this one console. And you can use their Grafana alerts. You can use Prometheus alerts, etc. Supports PromQL, all the standard query languages in Prometheus. And it's well suited for fleet, cross-region, etc., which also plays to the fact that it's multi-cloud and portable. So you're not getting this lock-in. So you can see why it's been a great tool and very well embraced by the community. So now that brings us to why Oracle Unified Observability. So one of the big aspects, we take advantage of Grafana and we bring a number of things to it. In particular, these exporters and client and server technologies that we've created. So it brings metrics, logs, and tracing across the app and database tiers. This is very unique and something you don't see elsewhere, which is, one tool for metrics, logs, and tracing. I'm going to say metrics, logs, and tracing probably 100 times during this presentation, but one tool for that, but one tool and technology stack to trace from app into the database. Okay, and you don't have to go from one console to the next, and I'll elaborate on that. Unified secure access to metrics. No need to access the logs directly. That's a huge feature because, and I'll elaborate on this when I talk about the exporters, but you're able to go through the front end and customize what you want from your logs rather than grab the entire logs from the back end and push them out, which in the cloud and things like that may just not be possible for security concerns. So I'll explain more about how that works and what I mean there in the presentation. The queries that are used are bring about or exploit the power of SQL, because you can write queries just as PromQL was designed around SQL. You can use SQL queries for all of these metrics, logs, and tracing. And then tracing into the database, again, is not just up to the database, the client edge, it's actually into the database. So you're getting tracing from end to end. Taking advantage of all the security and auditing in the database, you don't have to use a separate security model, even if you're in Kubernetes. You get to inherit all that security. You get to inherit all the high availability of the database for storage, etc., and all the different data types. If you check out some of our other sessions that talk about the converged database and support for all the different data types and transaction models, that's part of it, and that's including in container. So data types within the database, but also database types, whether it's cloud, on-prem, within Kubernetes, Docker on Kubernetes, etc. But at the same time, this is not limited to the Kubernetes environment. The actual observability is not limited to that environment. And then I'm going to talk about how you can set this up with a Kubernetes operator. Works well with CI/CD pipelines, of course, and the operator facilitates that as well. And as I mentioned, the multi-cloud aspect. Okay, so let's start to get into some more of the particulars. This is what the Grafana screens that I'll be showing a bit more of, but just to give you a taste, the tracing from left to right, tracing logs and metrics, and these are all correlated. I'll show a short demo that brings this about. But we'll start with the metrics exporter. So as I said, a core part of this architecture are the exporters that are all for metrics, logs, and tracing. And what they're all essentially doing is querying the database, getting some information, and then translating it into the appropriate observability format. So in the case of metrics, that is, the very prominent open metrics, the very prominent Prometheus format. So what you have here, and this has been out for a bit, a metrics exporter and a little snippet of some extremely simple config example. And that's where you have a basic context, metrics description, and then a request. And the request is a SQL query, which, as I say, can be any SQL query that the user wants. Okay. And so here we have a very simple one. And then you see in the metrics description, total subscribers in this case indicates a label. So just with this simple, it's really just 2 lines. You have exported from the database information about transactional event queues and put it into Prometheus format with labels, all the searchability that Prometheus has. And then that is in turn, the metrics exporter presents an endpoint with these metrics that Prometheus scrapes and hands over to Grafana for viewing. So the metrics, these exporters are run by themselves. They're a separate entity, if you will, component. And that's how the architecture works. Okay, as easy as that, a couple lines, and you have all this metrics information. So I'm going to show a very quick example of that. So here we see a basic Grafana dashboard with metrics from the exporter for transactional event queues. And I'll go over some of what these are, but this is basic queue information. And what I do in this quick demo is I'm in queuing. I have a thread in queuing a number of messages and another dequeuing it, okay? And so we'll see that here. What I'm going to show first, though, is this alert definition. So this is an alert that's set up in Grafana, very easy, to send an alert if the dequeue rate is half of the in-queue rate for a given period of time. And so we do the sum, the promql syntax, and give our condition. And then we can check the query in Grafana. Very handy. And then we can say if this condition lasts for a certain amount of time, send an alert. Okay. So then we can trigger this condition by stopping the dequeue thread. And we pop over to the console. Eventually, you will see, that we've induced this condition to set off an alert. So a couple of the stats here, you see the overall stats, the queues, the topics, the subscribers, number of subscribers, queue depth, message latency, the in-queue rate, the dequeue rate, and then our dequeue rate and in-queue rate. And we see that has dropped under 50 already. And so we're going to hit that condition very soon. This is with a time lapse, this demo here. But we see the condition has been hit. And we can then go ahead and bring up the dequeue thread again to relieve the condition. And we set up a channel for Slack here to get the alert notification and also the resolved notifications. And this is all in a observability workshop if you want to check this out. But setting up the exporters is a matter of running one script. It picks the database you've set up. You run one script that sets up the unified observability exporters, and then you can tweak the app and the database and things like that. So you may want to check out that workshop. Okay, the next exporter we'll discuss is the log exporter. Probably one of the simplest ones, but maybe one of the most powerful ones as well, because what you're doing here is exporting any arbitrary information from the database. And what's nice about the Oracle database is all of the alert logs, trace logs, and things like that that are written to disk are accessible with SQL queries. So that's very powerful because, as I was saying before, you can go through the front end, through the SQL end, do robust queries. When I'm testing this, I literally look online and talk to customers, top 10 queries for finding performance or whatever it may be. And debugging, all troubleshooting, things like that. And you can put anything in here. And it's nice because, as I mentioned, you don't have to bring out, the full alert logs, say you just want one field from the, a couple of fields from the alert log, couple fields from a particular application table, any information, you can bring that out. It's written to the log exporter, which is then pushed via Promtail to Grafana Loki for storage. And then Grafana can show those logs in the console, okay? And at the end of this presentation, I'm going to show you how everything is side by side. Metrics are aside, logs are aside traces. So, you look at the console and you can line them up and correlate them very nicely. Instead of going, I have my metrics here, now let me dig into my logs. Like I say, sometimes you can't push the logs in a cloud environment. You don't want to, have to go and access the logs that way. If you can do it from the front end, it's more customizable, it's more powerful, and it's more secure. Now we go on to the final exporter, the final aspects of observability, which is tracing. And as I say, I really like these three. They each have their own characteristics, and tracing is perhaps the most unique, because this is a trace, as its definition is, it's a trace through the system, the multiple components involved. So you're involving, the entire flow of whatever request or workflow you're dealing with. And so it involves the application. And this is, as I say, this is very unique strength in unified observability. But it can maybe be a little complex because of all the different parts. So let me break it down into its components and explain them. So we have the application, and it's creating traces and then calling into the database. And as I say, in most other systems, that's where it ends. You get your whatever you had in the client before you called the database, that's all the information you have for that trace. And then you need to go over to the database and connect the dots, sometimes with timestamps and, very primal approaches that exist today. But if you could take that trace that's on the app and flow it into the database and connect the two in the trace collector, you could then see an end-to-end trace from the app into the database. And that's what we've done, okay? And so there are a few things that we've added, and we're continuing to add more, particularly on the server side, but we have a lot on the client and trace exporter side now to make that easier to use and more powerful. So one of them is the tracing agent. And what's nice about the tracing agent is it uses that open telemetry tenet of not requiring code to be modified. So the tracing agent and all of the languages have some type of equivalent of this. In Java, you can hook up a Java agent to a Java class, and it uses bytecode manipulation to intercept calls. And so in doing so, we can use that and the OpenTelemetry interfaces to actually inject and retrieve information to do tracing, again, without touching the application code, all right? So let's take a little closer look at that. What's being provided is a new interface called Tracer. And as you can see, it has a class called round trip. And this is called before and after each call to the database. And so in that round trip method, there's access to all of these methods you see on the right, all this information as far as the SQL text, the database operation, and things like that. And so this agent, which is a separate jar, by the way, this is not part of the driver. It's kept nice and decoupled. This agent can then do this, whatever the user wants as far as OpenTelemetry traces. If they only want certain spans to be sent to the tracing collector, want to do any kind of sampling, anything, it's, fully customizable, but there's no need to touch the application code, like I say. So very nice.
So, hey, Paul, does the tracing agent run in the database or it's outside the database?
No, the tracing agent attaches. So if we look at this line here, you have your normal, whatever your app is, you pass in this argument, and then you just add the jar to it. So it's nice too for, say Kubernetes environments. You can just have a sidecar or an init container that adds this to all your existing microservices.
Right. So
And then
no changes to the applications. You can just
exactly.
add this to it, and your tracing exporters run outside the database as well.
Exactly. That's exactly right. Yep. It's their separate component, or the exporters is a separate component. Yep. Yep. Thank you. And this is an example of the tracer, the span that tracer has created, in this case in Zipkin, that shows this information that we saw in that tracer interface, that callback. Okay. Now we go to the exporter that Sanjay was alluding to, which indeed is its own process, just like all the exporters, is its own separate component. And by the way, these all three of these exporters are part of the unified observability exporter, and we'll show the link for that at the end, how you can get a hold of that. So you can run all three in the same process, or each in a separate process, things like that. But they are their own component, and so it sits outside the database, as you see here. And, in addition to being able to create spans, what that tracing agent is that we were just talking about is an agent that then propagates the trace ID into the database. And that is then stored inside the database. Okay. And that's the connection I was talking about, actually. There exists for decades now this ECID, but a new devoted element called this trace context has also been added. So again, it's dynamic. You can use either, but that's how it's being propagated to the database side. And on the database side, the trace exporter is querying the database for these IDs, creating a span, and then handing that span to the trace collector. So then you have the traces from the client side and the traces from the server side. They're put together with, that's OpenTelemetry. Tracing collectors have the ability to put traces together from different processes and then present it to Grafana. So if we look at the tracing exporter configuration, similar to the other exporters, you can put in any SQL that you want. You identify the tracing field, duration field, if you want to pull that information from the database for creating spans, and the description, and it generates those spans from the query elements. So it'll create a trace ID span with whatever information is in this query added as tags on that span. Okay. And then that's presented to Grafana.
So, Paul, we have about 5 more minutes, so let's
Yep.
maybe get to a demo or something that you want
Yep.
to.
The demo's coming right up. Thank you. Yeah. Thank you for the time check. So this is what it looks like. You can see the client. This is from the client side. Spring Boot application has sent a span. Oops. Oh. And then the child added by trace exporter is a child added from the server side. And you can see that there's the SQL bind value that you could only get on the server side. So I use that as kind of a litmus test. You would not be able to get this from the client side. And so that kind of proves out the fact that you can get client and server side aspects. And this slide is just showing, you can bring them all together. This is the three exporters and the unified observability for all these use cases that, I've been talking about. Now let's look at some of the features in Grafana as far as bringing all this information together and also doing metrics to logs, logs to trace, trace to log correlations. And I'll do that with a quick demo here. So here we see a console with both Kubernetes microservices and database metrics all in one console, a front end and an order service, right? And we put some stress on this for the place order operation. We can dig deeper into this metric, okay? So we see, the response time changing for this metric. And then we can go ahead and split the pane and choose another data source for the other side to compare. So on the left, we have metrics. On the right, we're going to select the Loki logs. Okay. This will bring up the logs that correspond to the metrics on the left-hand side. So you select that link icon on the top there, and anything on the left side matches that on the right side at the same time, okay, and vice versa. So for logs, you have the ability to search by all these different labels. And so what we're going to do is we're going to select the logs for the order Kubernetes microservice and the order exporter for the order database. Okay, so we have the two tiers here, and they're going to be intermixed. So we go ahead and run this query. We will see the logs, as I say, from the Kubernetes microservice and the database service at the same time as the metric that we see on the left. So one console for metrics and logs, okay? We can then go into the logs, and I don't know if you can quite tell, but some of the logs have a green tint to the bar on the left. And that means that there's a corresponding span that's been detected and extracted automatically by Grafana for that log. And so it creates a link. This is such a great feature, so powerful. It creates a link from the log to the corresponding trace. So if we click on that, and we're using Jaeger in this case, that takes us to the trace, and then we can see a trace all the way from the app tier into the database. And that includes, by the way, REST calls and messaging. So adding the message tracing is another unique feature. The assumption should not be that all communication is over REST. As a matter of fact, most app microservices are more and more event-driven. And we see all the details as far as the SOG ID, order ID, ECID tracing, etc. Saga ID is another aspect. You should check out our Saga workshop. That's a Saga engine in the database for transaction integrity. And we have tracing all the way through the Saga engine as well. So hopefully you see the power of bringing it all into one console and having a view such as you see here to correlate and dig down on metrics without, like I say, copying timestamps and IDs from different consoles.
And if you don't do these in a single pane, then you could think about three panes coming up, like Kibana for logs and
exactly.
Jaeger for traces and Grafana for metrics.
Yep.
Just the correlation is a nightmare there.
Exactly. And that's what we've heard. We're working on the toughest problems, basically. These are what developers are saying. This is the pain points. And then just very quickly, we have a Kubernetes operator, which we are adding an observability controller to. So you say, as simple as this config, this is my database, set up all this exporter and Grafana that you just saw with this one CRD. So, making it simple is the other big thing. And this is a app we're using to show off all those features, messaging across multiple databases for the microservice model, etc. And so with that, I really appreciate your watching and hope you will contact us and also check out these resources on this page here.
So Paul Parkinson, paul.parkinson at oracle.com.
That's right.
And Sanjay.Goil at oracle.com.
Yes.
Right. And, please do check out our other talks at Oracle CloudWorld that tie microservices and modern app dev together. So thank you. Thanks for attending this talk.
Yeah, thanks, everyone.